Hey everybody, this is Brad Dyke, and today's video is about operations and how the industry is affecting the operations environment today. As many of you have probably heard the term, the world of enterprise operations is transitioning. Well, truth is, it's always transitioned. It's never stopped. All the way back to when I began in the early 90s, it has never not transitioned. And if you've learned anything about the industry of the IT world, you understand what's called product lifecycle. What is product lifecycle? Well, basically, it's the product's ability to meet and get your goals accomplished. That can be based on a software tool, a hardware tool, a combination of hardware and software tools, or a combination of services by third-party providers and your resources you might have locally or distributed within your cluster environments, i.e. hypercloud environments such as Google and AWS and Azure, as an example. So we're talking to that. So with that happening, what is the key thing that I saw 15 years ago I'm seeing coming back yet again? And that is basically that when you're in an environment that transitions from one state to, for instance, one vendor to another vendor, to another vendor, to another vendor, i.e. a Dell server to a Compaq server to a Lenovo server to a Supermicro white box server, and so on. Or it could be, well, I was housed in this data center, but I've been migrated to that data center, and now I'm in this data center, and so on and so on. Or if you're in the multinational and multi-tiering environments, you have a local data center, you have a cloud environment acting as a DR, and you're using a second cloud provider as a business continuity integrator with your local data center. So this is what I'm going to talk about. So how do you get from being stuck in a proprietary state using either proprietary software that a cloud provider has put you into by giving you a great deal, it's going to be super cheap, in 2 years we're going to charge the heck out of you. Or you're on a platform, I say the terrible word, Cisco, and you are not able to transition and you're forced to buy new licensing agreements. You're paying what we call a lot of soft costs with no real legitimate in-hand hardware resources, and it's just driving your costs up. SPLA agreements, licensing control agreements, hardware licensing limits. In other words, they put CD keys on your motherboard's ability to do a particular class of storage, or you have a MOF key in the back of your chassis without the key being present and replaced every couple of years for a couple $100,000. You don't have the encryption keys, so you can use the hardware you own. Oh, it gets really messy. So, for all of you, here is that suggestion. First things first, just as we do in DevOps, as we did in operations, you need to document everything you have as it is today. How does it work? What are the steps to deploy it, maintain it, and transition it? Because you might have an issue that exceeds beyond your business continuity model. That's your backup plan in case you lose a data center. And you have another site that can offer some connectivity still, even though you've lost your primary site, you're still servicing your customers, you're still making money, but not as quickly while you're recovering your data center. That's a business continuity model. Versus a DR, which is basically you got 24 hours to spin up a whole brand new paired 25% representation of your production environment, and it's got to work pretty quickly. So the only way that can be done is document. Hire a document writer, a technical document writer whose only job is that focus. Don't distribute the workloads of that document writer over multiple departments. Every department has their own requirements, but operations has a huge critical role, and you really do need a dedicated document writer for that role. With that being said, the second thing you have to do is stop locking yourself into systems, tools, software suites, and other things that are proprietary in central nature if you can. Now, this pertains to using DNS services, this pertains to using backup tools, this pertains to using replication tools, this pertains to a lot of things. Everything in the world can be done agnostically away from providers and data center services. What do I mean? Well, if you're on AWS, for example, or Google, they have an internal process using and working very efficiently and very cheap on their environments for you to back up your stuff pretty quickly, fast, efficiently, and it's cheap. The only problem is it's totally self-contained and is not transferable anywhere else. It's all inside their resources on their platforms using their protocol processes. And you have to go somewhere else inside their cloud and rehost all your stuff. Hence, you're pigeonholed into the cloud provider. There are plenty of backup tools out there that can do the same functionality, and you can use S3 buckets or other variations of cloud provider common storage buckets to house your images for your backups. Or if you do what I strongly recommend, your backup images are coming to your main data center or your main repository site. If you've closed all your data centers, the one thing you should always still have is a archive site that will back up and replicate all of your intellectual property and your core requirements in a system that you 100% control, and it can agnostically redeploy anywhere you want to go. So with that being said, understand the nature of this. When you document your process, that was the very first thing I told you to do, you're going to see how you're trapped. And you know what? Some of those services are okay. There's nothing wrong with them. Like CloudWatch or Service Alerts. You know, that CloudWatch belongs to AWS. Service Alerts are existing for Azure and for Google, and so on and so on. Those are fine. You can use them. They use, SNMP, so the communication traffic and all of that is okay. You can leave that behind and kick off a new alert service process. It's not critical. And there are other functionalities that can keep you in your price budgets. But the key thing is, can you agnostically bring up everything you have that you absolutely need for your production if you can't be allowed to stay on the cloud provider or the data center or the location you're at because of a moratorium, a contract agreement, or a competitive NDA or something like that? Those can get you just as much as costs and availability. Availability meaning you can have multiple sites for higher availability for your customer base. So it's a balancing act. So the end result is you need to get 80% of your environment to an agnostic state. In other words, using common tools, open source tools like Docker and so on, that can be handled locally on the instance itself. Not using proprietary Linux operating systems that belong to the manufacturer as the cloud provider, i.e., for an example, AWS Amazon Linux. Great tool, really nice and everything, but consider using Ubuntu instead, or Alpine, or Rocky, or some of the other ones that are out there that have no strings attached. And yes, AWS has strings attached to Amazon Linux, both for good and bad. But the point is, to be able to bring up your own instances, you can still bring up a Rocky instance inside AWS or in Google or in Azure because it's just a Linux instance. And you can do that in containerization as well as it being a functional instance. The key thing is that backup is not native only to AWS. It's a Linux backup on a Linux box that can be restored anywhere else without any complications. The same way with your services. I hate to say it, but if you use a cloud provider's core services for your functionalities, such as email and so on, it might not be a very good idea. It might be more advantageous for you to utilize a third-party vendor instead of using the internal provider. Now, balance your cost, got it. But when you do the math, the cost may be greater down the road because you thought you could save a couple of bucks here. What I mean by that is an example, Elasticsearch, which is a caching tool designed to help and assist systems so that they can respond quickly by having reserves up front in front of the main system, so the users come in and they get a really nice refresh on their screens. Without it, it's, you tend to see the dial in the middle of the screen kind of spin, but with it, it's a great benefit. Well, obviously, cloud providers come in with their own version of Elasticsearch, and like, for instance, AWS uses OpenSearch as an example. It does the exact same functionality, it's internalized, and it's cluster distributed, and all of those wonderful good things, but it's 100% proprietary that only gives you 40% functional administration control, and you're handing off the administration powers to AWS. Well, if you go to Elasticsearch and use the services there, and you put them into an MSA and an MOU agreement, Elasticsearch is providing a single service. There is no way to put a non-binding NDA agreement of non-compete against Elasticsearch unless you're an Elasticsearch company. And that doesn't make any sense now, does it? So your chances of running into a problem with that third-party provider who will run on any system you got, in any format you have, under any standard you have, is better than working with one that is designed to silo you into the cloud provider. Now, all cloud providers must provide 100% compatibility. They have no choice. So they're not going to turn the switch off on that front. But what they can do to you is they can give you incentives. Take these price points, we'll take money off the top. Start using this, we know we'll get the money back later because we are going to charge you. And they do, by the way. You deviate even 5% off of your cloud provider's budget, even with alarms set up and everything, you're going to see the charge. And it's going to be, wow, that's a sticker shock. I didn't know we breached, our current usage requirements. And it can get fairly complicated very quickly. So understand the nature. Document to know what you have. Move what you have into a more agnostic-friendly footprint. And from there, the small services that you do end up leaving behind inside all the cloud services, providers, or data centers are the minimal that you can have and have no true bearing directly on your services because that's not something any of them really want to do. You see, there's the secret sauce. They don't want to run your production environment. They want you to cover that because they don't understand how you do it. It's your IP, not theirs. So with that being said, as your intellectual property, they want to get everything else around you. So all of those little low-hanging apples, price point-wise, they look really tempting. And you do start to use them, and they give you some really good results because they do some cute little tricks in the background. For instance, like they give you really high-end storage resources, so the turnaround is rapid on Elastic functionality. But then as you grow your Elastic, they can rebalance that out and get their money back. It's pretty interesting how you do it. I spent half my time just trying to figure out how are they making money on this and getting us in a situation where we can't step away, not because we want to, but because we have to. There's the secret ingredient to our dilemma. Understanding the nature of that is by systematically breaking these systems down, getting them in a progressive roadmap, to 18 to 36 months windows to get yourself to a better place. You're still using all the resources you have. You probably have saved money, and that's not something they want to see. But you're now agnostic because technically speaking, you could just go into your own back garage, build your own mini data centers you see back here, and just quickly rehost all your stuff and reroute the IPs to your DNSs, and voila, we're operational again. See what I mean? It's difficult to plan these things out because you have a lot of moving parts. When I joined the company I work for, they didn't have a lot of moving parts, and so their ship turned pretty doggone fast. But they didn't document the processes, and they didn't know what they really had. And not everybody had the skill sets that were needed. And the only way we could identify those skill sets is by documenting what we have first. Tearing it all up in little pieces and parts and pieces, and then bringing them back in to formulate the picture that which we're trying to accomplish here. And with that being the case, we're actually going to be able to set this up in a pragmatic 1, 2, 3 process to get these systems to basically take one node offline and bring the other node right back in the same instance environment, and nothing was lost. No connections were lost. No users lost their interfaces or anything like that. They just got what they needed, and we went a little more agnostic over time. It's not an easy process. I mean, when you're looking at doing clusters and you're working in environments where you have integrations and so on and so on, it takes time and it takes planning. But all in all, inevitably it works. Well, this is just a little 15-minute blurb that I wanted to throw out there to you guys. My experience professionally is I have been in the world of many, many data centers in one environment. That would be the DoD. I've been in the world of massive single data centers that did not have distributed connectivity and couldn't do business continuity if it meant their lives. I've been in transitions, and I've migrated data centers, and I've migrated data centers into cloud environments, and I've done hybrid multi-clouding as well. And those are with companies with, like I said, Department of Defense, Ford Motor Company, LabCorp, TAC, NetApp, EMC. I've had a long roadmap of these kinds of experiences, and it gravitates to that 15-year cycle. Like I said, we become independent and agnostic. 15 years ago, it was Microsoft Server. You didn't need anything. You just had to have a server. That was it. We could get services up and running. It was very clean cut. We could grow into this thing called Active Directory and LDAP and so on. And then, of course, things became proprietary again. And cloud came on the scene, and so on and so on. These cycles are affected by what we call the software and hardware cycles. Now, what those basically are is, in the 15-year cycle, you have smaller cycles. You have the revolutions of hardware, you have the revolutions of software, and you have the revolutions of hybridization. Hybridization represents hyper-threading, tiering, setting, threading, containerization, VMware, virtualization, all those kind of functionalities. And so they've got to go through their processes. So hence I term the loosely about a 15-year window. And it should compress over time to be fewer and shorter time periods, because before that 15-year period, it was 20 years. And before that, when I came into the business 35 years ago, I was on the back end of the 20 going into the 15. And we went into the 15, and it's been 15 years now. And so I'm seeing this for the first time, an entire complete loop of all three sub-loops of this process. Any veteran will know exactly what I'm talking about. Back in the days of fiber channel hard drives and SCSI pin, 80 pin output drives, and IDE and RLL and MFM drives and all of that, it's quite an interesting experience to have when you've gone from, let me see if I can show you an example. Oh shoot, where'd it go? Give me just a second here real quick. Okay, so this is an representation of what I mean. In 1987 to the 91, we had something called WordStar and IBM, and these systems called AMDAL systems existed. These were called mainframes. Okay, so back in the day, we used to have these hard drives. Basically today's modern hard drive as an example of technology. Back in my day, this was a hard drive. Some of you might recognize this as a hard drive platter. And as the PC industry began back in about 30 years ago, the hard drive platter went from so big to this big. And this is the era of RLLs and MFM drives. And then over time, we had this standard called IDE, and they helped develop a good standard. And eventually, over time, the platters got smaller. I mean, here's what they used to look like. And as you can see, one is slightly bigger than the other. And then eventually, it got down to just this. It's a hard drive. See how thin it is? called an NVMe drive. So back in the days of enterprise, the more you have of these, the bigger you were. Not anymore. The reality and the life cycle that we work in and function in is a repetitious process. And as soon as you figure out how to get yourself in an agnostic state, you'll want to probably do your best to stay as close to that as you can. But you'll probably, the next big round will be the third-party vendors who will come to the table who are not resource providers such as compute, RAM, GPU, and storage and network bandwidth. They'll be the other kind of supplier. And it's a balancing act that's becoming more definitive these days because you got to be careful. I mean, if you get a giant contract with a big company and they're a competitor of your cloud provider in an indirect or a direct way, and you sign the NDA, you got to get off that provider and you got to hop over to another provider. And hence, we should have been agnostic to start with. That was the more practical plan. Well, I just wanted to spend a few minutes here with you guys to talk about operations and DevOps and why these processes are so critical as you're going about it. I have found that I'm one of the very few people who talk to these topics. I do get hits on this, which is impressive. I was surprised. I didn't think, people who would, wear the mantle of operations for IT and or DevOps processes or the integration of both going forward, took the time on YouTube to see if there was anything out there, and that's why I make these particular types of non-hardware or PC related stuff, but how you manage it with people, places, times, and resources. But with this to be said, I hope you guys have a great year. God bless. 2025 is coming, and there's more to come. Take care and be good.